Hello.
Yes, bro.
Welcome to Limits Day 2. If you're following us in this lovely series, Limits Algebraically. All right. Guys ready?
Yeah.
All right, let's go to limits. All right. A limit of a constant function, okay? Ooh, that looks pretty. All right. So, if you have a constant function, okay, like this, where it says like the limit of k as x approaches a, this answer would just be k itself. All right. I'll use numbers though because numbers are a little bit easier.
I agree.
So let's say I had the limit of 3 as x approaches, I'll pick a number, -2.
It's gonna be 3.
Okay. So do you, like when you look up here at this graph of 3, what's the height of this graph?
3.
Three.
The
3.
negatives never change.
So even if I go to -2, my height is still
3.
3. If I go to 1, my height is still
Three.
3. So this limit would be 3. In a second, you're going to kind of understand a little bit more why that makes sense too.
That makes sense.
And I'll show you right here, is when we're doing limits, the easiest approach to limits is you're going to always try to plug the number we are approaching, you're going to try to plug in the number we're approaching, okay? And what's going to happen is you're going to have like 3 cases. If you plug the number in for this one, the number, hold on. You're gonna plug in a number, right? And there's gonna be 3 cases. One of the cases will be that you get back a number, right? That number will be your answer. You're done. It's like, oh, that's nice and easy. Second case comes along and you get this 0 over 0. This tells you something is going on. And what you're going to have to do is you're going to factor, cancel, and then re-plug in. And now you should get a number, okay, after you do that. And then that number would be your answer, okay? The third case is you're going to have a number divided by 0. That one tells you that we have like a vertical asymptote happening, right? But we're going to make it easy for you guys because we normally would like do this approaching from the left, approaching from the right. But when this happens, when you get number over 0, you're just going to write D and E. Okay, so it's going to be 3 cases, right? You are going to pop in a number. If you get a number, you're done. If you get 0 over 0, what do we have to do? All right. If you get a number divided by 0, D and E. Ready? Set? Let's go. All right, let's go to the next one. Let's do the examples. All right, so let's show you guys what's happening. So try number 1, right? Let's plug in 2. See what you get.
I got a number. 3.
Then you're done.
So the answer is 3.
All right, just don't call it out loud.
Wait, what's the answer?
Okay, so you guys ready?
Yeah.
All right, so remember, this is okay. That's okay. You can get 0 as an answer. All right, let's check out the next page. All right, let's do, let's do 3. And then I might have you do like 5 on your own. So let's look at 3 together. you have to plug this. You know what I might have you guys do? We want to now factor. Okay, so I would factor your denominator first because that's a little bit easier, right? X squared minus 1, that's going to be x minus 1 and x plus 1, right? That's your dots, right? Dots. All right, then you have a regular trinomial who multiplies to 3, 3 and 1. So this is nice and easy. All right, so who do you set, like, who do you see as the same? The x plus 1, right? So I'm going to cross them out. Rewrite.
Is that a hole?
Ah, very good. Yes, you guys remember. Oh my God, that's so cool. Yeah, that's what's happening. Is so if we tie in our graphic, that would be a hole, which is what's causing like an issue in your graph. Right? So that guy causes this issue, and we can't like evaluate a limit there. And now we plug in -1. Oh, I'm so proud of you guys for remembering. Yes. All right. -1 plus 3, -1 minus 1. And you might get like fractions here and that. I mean, this one isn't a fraction, but whatever you get, you just 2 over -2, -1. Yeah. So don't do exercise 4 yet. Now try 5 on your own. Like, cause 5 is like number 3. So let me just. All right. So we finished this up. We did a piecewise here. Just want to show that off. You guys did.
Yeah, can you
Can you
do
do
example
7 with
7 real
us?
quick?
You want me to do 7 with you guys?
Yeah, just this way we know if we have to
I didn't
solve
need
that
it.
out.
I can do this with you. I don't care.
Zero.
All right.
No, like, I'm pretty sure we're all up to the
No,
point where it's like,
We got
All right, hold on.
4.
yeah, we already have that.
I know. I gotta do it though. 0 over 0. All right. So you've got x plus 4 over x plus 4, x squared minus 4x plus
Alright, wait,
16. Do you need me to go through on how to factor that?
Yes.
Okay, so you want to do cube root of x to the third,
cool.
cube root of 64.
I'm not doing that.
No, but what are we doing here? Good pickup. Right, so now we're doing the same, right? Same. No, 4.
So that
because
means
it's
just
cube root.
cross out the, okay, so Sonia.
Now, I will tell you, you have to be careful here because I know the errors that like you guys tend to make. Or it was.
Now let's go. Alright, let's go.
All right, let's go.
So
Okay,
we cross
so-
out we cross that out? Okay.
But what do you have to put up here though on
A
top?
1.
A 1.
Oh, I didn't do that.
I
So it's
know.
1 over,
Okay.
Yeah, I don't know. Wait, Michelle, how did you get the bottom one?
So you want to do your sum and difference of cube roots, right? So it's the same formula from like the do now, but because this is a plus, I have to start with a plus. So it's same, opposite, always positive. Right? Okay, so now I do the cube root of x. That's x. Cube root of 64 is 4.
it's negative
So-
4x.
I have x plus 4, right?
Back to that.
Then I square it, multiply, and square, right? Okay. You're going to have 1 divided by, you want to replug in -4.
Oh, yeah.
So it's going to be 16 plus 16 plus 16, 48.
Ooh.
Quick maths.
Nice job. So 1 over 48.